Hi everybody, here's a video on graphing linear inequalities. In this video we're going to focus on graphing single linear inequalities, making sure we understand what they mean and how the answers should look. Here are some steps for you. These will be on the page, but you might want to come back here and look at them again if you have any questions. Okay, so we want to sketch the graph of y is less than or equal to 2x minus 3. What this means is, on our graph we want to identify all of the points where 2 times the x value minus 3 is greater than or equal to y, or where the y value is less than or equal to 2 times the x value minus 3. We're going to start by graphing it as if it were an equation. So we're going to pretend we're graphing the equation y equals 2x minus 3. So y-intercept of -3, a slope of +2, so on and so forth. We're going to use a solid line if we have a less than or equal to or greater than or equal to. Just like in our last unit, we used a closed circle for that type of inequality. And if we have a strictly less than or a strictly greater than, we are going to use a dotted line. So for this one, I'm going to use a solid line. So now that I've done that, I'm going to test a point in the original problem. So I'm done with this equation, and I'm going to go back to the inequality. The point that I almost always use is 0, 0, because 0 is the easiest number to work with. So I'm going to plug that 0, 0 into the original inequality. So 0 is less than or equal to 2 times 0 minus 3. Is that true? Is 0 less than or equal to -3? It is not. And what that means is that this point doesn't work. When a point on one side, so in this case above the line, doesn't work, it means that none of the points on that side of the line are going to work. So we're going to try the point 10, 0 this time. When we plug that in, we're going to get 0 is less than or equal to 2 times 10 minus 3, or 0 is less than or equal to 17. That is true. So this point does work. When that happens, we're going to shade all of the points on that side of the line. And that means any point on that side of the line, like 0, -4, or like 10, -10, any point over there is going to work. All right, one more example. We want to sketch the graph of 2x plus y is less than 8. So we're going to graph this just like we would have graphed the equation 2x plus y equals 8, except we're going to use a dotted line because we have a strictly less than sign. So that line looks like this. It has an x-intercept of 4 and a y-intercept of 8. And we're going to connect those with a dotted line. So now we're going to test a point in the original problem. Again, the point we're going to use is 0, 0. And we're going to see if that works. Now this type of inequality, one that's written like standard form with x and y on the same side, make it really easy to test the point 0, 0. Because we always get something like 0 is less than 8. Now that is true. So that means that this point works, and we're going to shade out everything on that side of the line. And again, what this means is anything on that side of the line is a solution to this inequality. -10, 0 should work. And 0, -10 should work. And 3, 0 should work, for example.